Hi and Assalamualaikum. My name is Nur Agnia binti Muhammad Nazlin and my metric number is CF210324. I would like to present about introduction. First of all, project background. This project is to provide an exposure to the student on the application of mechanical and electrical system in UTHM buildings. Next is location. For this project, an academic building in UTHM, which is at Block E, has been chosen. Next is purpose of the building. This academic building is consisting of classrooms and concrete laboratories. It provides spaces for theoretical learning, which is classrooms, and technical experimentation, which is concrete laboratories. The first picture is at one of classrooms at Block E and the second picture is at concrete laboratories. Next is factor the selection of the building. This building is chosen based on its use which aligns with UTHM educational goals, emphasizing practical, skill-oriented learning in scientific and technical disciplines. This selection caters to the university's focus on providing specialized education in fields like engineering, technology, or science. And lastly, the importance of efficient mechanical and electrical system. First of all, for maintaining optimal laboratory conditions. Second is for ensuring safety, and lastly, reliability and sustainability of the buildings.
Hi and Assalamualaikum. My name is Muhammad Hassan Bashri bin Faizal, CF210331. Okay, for electrical system manage the flow of electricity, transforming energy source into electrical energy, in which electrical system are crucial for both technology advancements and social development. They manage the flow of electricity from power plant to substation, enabling the production of energy from various space. The transmission phase organize the movement of electricity with transformers, maximizing voltage level, in which the level energy is essential for business, industrial operation, lighting, and for home usage. It is wide range variety of application and adaptability make it a pivotal part of the modern world, in which promoting social development and enabling technologies innovation. Power distribution systems are crucial for connecting end user to the larger power grid. Local substations serve as hub, consuming energy from the larger grid and conditioning before it distribute into the distribution line. Challenge include growing demand, aging infrastructure, integration of renewable energy source. Power distribution systems are essential for effective and timely power delivery, requiring adaptation to the challenge and rapid technology advancement. Radial system distribution power among multiple consumers, while loop system provide more planning flexibility. Network system have multiple connections. Careful consideration must be given to the complexity and cost during the planning and implementation.
Hi, my name is Muhammad Halim bin Muhammad Hanif and my matrix number is CF210186, and today I will tell you about our electrical distribution system on Block E. The selected buildings for our project, Block E, are using two secondary energy resources. The first primary resources would be directly supplied from power station from Tenaga Nasional Berhad, TNB. TNB retains electricity operation and distribution network activities are managed by the distribution division. The division design, builds, run, maintains and repairs and oversee the assets of the Peninsula Malaysia distribution network, which includes 33 kV, 22 kV, 11 kV, 6.6 kV and 415/240 volts. It runs a network of states and local offices to carry out its retailing of electricity business. These offices are used to buy electricity from embedded generators, market and sell electricity, connect new supply, offer counter services, collect money, run call centers and offer supply restoration service, and establish relationship with customers and the government. It was generated through 7 gas-fired power stations, 3 coal-fired power stations and 3 hydro power stations. A distribution transformer is an electrical component that lower the medium voltage it receives to lower voltage levels suitable for home or commercial use, which are typically 400 volts at 3 phases or 230 volts at a single phases. Second primary resources is solar power. The process of converting sunshine into electricity either directly through photovoltaics, PV, or indirectly through concentrated solar power is called solar power or solar electricity. The photovoltaic effect is used by photovoltaic cells to convert lights into an electric current. Concentrated solar power system focus on a huge region of sunlight onto a hot spot, usually to power a steam turbines using lenses, mirrors, and solar tracking device. Photovoltaic were initially solely used as a source of electricity for small and medium-sized applications, from the calculated power by a single solar cells to remotely homes powered by end-of-grid rooftop PV systems. A distribution board is a part of an electricity supply system that divides an electrical power feed into subsidiary circuits and provides a protective fuse or circuit breaker for each circuit in a common enclosure. It also referred to as a panel board, breaker panel, electric panels, fuse box, or DB box. A main switch is typically included, and more recently, boxes have been included one or more residual current breaker with overcurrent protection, or residual current devices. A distribution board is intended for home installation is referred as a consumer unit in the United Kingdom. A fuse box refers to consumer's unit where all the electricity is controlled and distributed. It is important to know where it is in your home because in the event of emergency, it is vital to find your fuse box with ease and turn it off to avoid any catastrophe. They contain three components: main switch, circuit breaker, and residual current device. Disposable fuses are used in fuse box to protect circuits from overload and short circuits.
Okay, when we look at this slide, the suitable electrical component that can be improved in that selected area in which E14, if I'm not mistaken, which is smoke and heat sensor and electrical light, emergency light. For smoke and heat sensor, in which it is a fire alarm device that combines two detection technology in one unit, in which a smoke detector and heat detector. This means it can detect both smoke and high temperature while providing an earlier warning of a fire than either type of sensor alone. Overall, the smoke sensor and heat sensor are a valuable addition to any fire system alarm, which is provide an extra layer of protection. It uses photoelectronic technology in which where a light beam is scattered by smoke particle, then it will trigger the alarm. For emergency light, well, an emergency light, as the name itself suggests, it is a type of light which is designed to provide illumination during power outage and other emergencies. They play a crucial role in ensure safety and navigation in dark situations. For the application, it is more suitable for crucial area, for example, an emergency exit, for safety areas and essential equipment location.
Okay, so next is lighting system including fixtures and also control mechanism. So a comprehensive lighting system for an institution building especially involve a thoughtful selection of fixtures and also control mechanism to ensure optimal illumination, energy efficiency and also user comfort. So here is the a few of lighting system including fixtures and control mechanism, which is LED fixtures. Second is daylight harvesting system. Third is motion sensor. Fourth is task lighting. Fifth is smart lighting control, and also the last one is emergency lighting. Okay, so next is lighting system including fixtures and also control mechanism. So a comprehensive lighting system for an institution building especially involve a thoughtful selection of fixtures and also control mechanism to ensure optimal illumination, energy efficiency and also user comfort. So here is the a few of lighting system including fixtures and on control mechanism, which is LED fixtures. Second is daylight harvesting system. Third is motion sensor. Fourth is task lighting. Fifth is smart lighting control, and also the last one is emergency lighting. Okay, next is common type of lighting system. So in the building, especially institutional building, there are various type of common type of lighting system, which is first is fluorescent lighting, which is this lighting is energy efficiency and also low cost. Second is LED light emitting diode lighting. So this is significant popularity in recent year for its energy efficiency, long lifespan, and also versatility. And next is smart lighting control, which include sensor, timer, and centralized control system. And last one is emergency lighting to ensure occupant safety during power outage or emergency situation. Okay, next, which is the last one, is recommendation. First, install dimmable lighting control to allow flexibility in adjusting light level based on different activities and preference. Dimming control are particularly useful for presentation, audio-visual activities, or creating a more relaxed atmosphere during certain class session. Second, opt for lighting with a color temperature, which provide a neutral white light that promote alertness and concentration. Third is design the lighting system with energy efficiency in mind that can utilize energy efficient fixtures and bulbs to reduce operational costs and also environmental impact.
Okay, hi, Assalamualaikum. I am Nurul Dejati binti Zamri, CF210212, and today I'm going to continue the presentation with the topic safety and security system. So, the first one, I will present about background study for safety and security system. Building safety and security system for electrical infrastructure have evolved significantly. Traditional fuse box have transformed into advanced circuit breakers with features like overload protection, specialized fire detection system for electrical fire coupled with smart technologies enable real-time anomaly detection and remote monitoring. This evolution underscores a commitment to enhancing reliability and safety through innovation. Okay, the next one, I will be present type of safety and security system, and we have here 9 safety and security system, which is circuit breaker and fuse, fire detection system, emergency shutdown system, smoke and heat sensor, fire extinguisher, emergency lighting, access control system, video surveillance cameras, and also intrusion detection system. And the next slide, I will show the photos for the safety and security system that available in this project. Existing safety and security system is just only fire extinguisher at Block E UTHM. The fourth one, I will present about safety and security system appliance with safety regulation. So here we have about 8 safety and security system appliance, which is circuit breaker and fuse, and I will show the photo of safety and security system with safety regulations. Okay, last but not least, recommendation for safety and security system in academic block E UTHM. So the first one is routine maintenance. For the routine maintenance, regularly inspecting electrical system, wiring, electric lighting, and emergency equipment in academic block E is vital for proactive issue identification. This approach mitigates the risk of electrical failures and fire hazards, ensuring a safer daily environment for students. The second one is check expiry of the fire extinguisher. Implementing a systematic check for fire extinguisher expiry date is crucial because regular check and prompt replacement of expired extinguisher contribute significantly to maintaining effective fire safety in academic block E UTHM. And the last one is additional recommendation. There are a few recommendation, which is 5 that I have list out in the presentation, which is emergency evacuation drill, well-equipped first aid station, security camera installation, adequate lighting, and also public awareness campaign.
In conclusion, the comprehensive assessment of electrical distributing, lighting, and safety system underscores their pivotal role in ensuring operational efficiency, safety, and functionality within any establishment. The electrical distribution system serves as a backbone, facilitating the seamless flow of power across various circuits and devices. Meanwhile, the lighting system does not only illuminate space but also contributes significantly to productivity, ambience, and energy conservation. Moreover, the safety system, comprising protective devices, protocols, and measures, stands as a guardian against potential hazards, minimizing the risk and ensuring the well-being of occupants and equipment. Through diligent analysis and evaluation, this report has highlighted the critical components, identified areas for optimizing and enhancement, and emphasized the importance of adherence to standards and regulations. Moving forward, continual monitoring, maintenance, and periodic upgrades remains imperative to sustain optimal performance, promote energy efficiency, and uphold safety standards. By integrating emerging technologies, implementing best practice, and fostering a culture of safety, the electrical distribution system, lighting, and safety system will continue to evolve, ensuring the reliable, efficient, and secure environment for all stakeholders involved.